So good evening everyone. Today we are going to solve Tipsy Guy, which is a challenge in Hyderabad West Code Practice Set 2. So what happens initially is Bob is a senior software developer. So when he's promoted, he gets excited and he starts giving party to his friends. So at the end of the party, he gets a little tipsy and he starts to wander here and there. Your task is pretty simple. You need to take Bob to his doorstep back in the shortest distance possible. So the problem seems easy only if you think of the problem in terms of coordinate geometry. So problem is pretty simple. It reduces just to two lines. It's Bob, he's at some other position. You need to take him back to his starting position from where he started, and those direction where he moves are given clearly in the sample input. So in the input format, the first line denotes the number of test cases t. For each test case, the first line denotes the number of directions he moves, that is n. Then in each line, you will have two integers. What are they? Their first one is character and the second one is an integer. Means suppose if n space 5 is there, so the Bob moves in the north direction and he moves 5 units distance. So after moving certain set of distances, he is at certain final position. From that final position, you need to calculate the distance you need to take Bob to his doorstep. So in order to simplify the problem, so if Bob initially moves north towards 5 units, so if you think Bob doorstep is at 0, 0 location, now he's moving 5 units in north direction. If he moves north, you need to think of it as a coordinate axis, and if you moves north, you need to increment its y coordinate. Like he moves north. Now when he moves east, you need to increase x coordinate. Now again he moves north. So whenever he is moving north, you need to increment y coordinate. Whenever he is moving east or west, you need to increment x coordinate. Suppose what if they say he moves west by 10 units. So he moves west by 10 units. West is along the negative x direction. So if he moves 10 units in the negative x direction, you need to subtract 10 from his x coordinate. So his 5 minus 10 gives you minus 5 and 10 if he moves towards the west. But they didn't give, so this is just for an idea. So his initial position at 0, 0 and final position at 5, 10. You need to find the distance between 0, 0 and 5, 10. So in coordinate geometry, you have the simple formula which we have been learning from first class onwards, which is square root of x square plus y square. So Bob can move in any direction from 5, 10 to 0, 0. You need to find the shortest path. So shortest path is essentially the direct path from 0, 0 to 5, 10, which can be computed like square root of 5x square plus y square. So the problem is a simple problem. And also we need to print the output corrected to two decimal places. So the format specifier you are going to use is %.2 and f since it is a float or a double. Let's start writing the code. You need to follow the input format. So initially it is the number of test cases t. You need to scan the number of test cases. Now for each test case you need to loop. So you need a loop. Now we have directions variable. This directions variable is just to keep track of the number of directions. Suppose he may give 10 directions, so you need to get 10 lines of input, each line of input giving the character and an integer. So that is for directions, and t is for test cases. So one more thing you need to observe in online judges is that after taking test cases, you press an enter. So that enter key must be taken care of, otherwise it will be still remaining in the buffer. So percentage %d(n) means /n means it will take the integer and just store it in d, and then it will discard the /n. Otherwise the /n may be present in input, and when you are reading the character, /n may be taken from the buffer and put into the character. So we get this problem when we try to read a character. So in order to avoid, we even scan /n and we discard it. We essentially make the buffer empty. So after scan direction, you need to scan two variables, which is the character and the distance mode. So let's take two variables, one for the distance mode and the other which represents the distance he moves in that direction. Now you can use if else construct and also switch case. Switch case will be better because we have only 4 choices and he can move only in one of the directions. So suppose consider he moves in north direction. So if he moves in north direction, you need to increment it in y-axis. Means he moves north, he moves towards the positive direction of y-axis. If he moves south, he moves towards the negative direction of y-axis. So you can always have track of few variables. Like suppose if you take a variable named a, like, and if he moves upward direction, you increment a by the distance he moves. And if you move south, instead of keeping another variable, we decrement it. And suppose if you moves in east direction, we increment it, since east is the positive direction of x-axis and west is the negative direction of x-axis. So essentially A represents the positive y direction movement and B represents the positive x direction movement. So this if he moves east, and this if he moves west. You can always keep track of separate variables. Like if you declare 4 variables, so you are wasting memory. Instead of that, north and south can be treated as one variable. If you move in north, if the character is north, increment it. If the character is suppose a south direction, decrement the same variable. So you'll be saving memory. So we'll take two variables named up and right. Up represents positive direction of y-axis, right represents the positive direction of x-axis. You need to initialize them. So you have all the variables ready. Now you need to just increment up. If he is moving north direction, you need to increment up. By how much distance you need to increment? You need to increment by the distance he moves. So okay, we didn't take the input here. For each direction we need to take the input. So you take the character in which direction is going and also the distance. Like if it's n comma 5, so n will be stored in C and also 5 will be stored in distance. And also don't forget to discard /n so that you won't take /n in C in the next input, in the next iteration. So you will discard /n. So this is important. So after reading into character ch and distance, now we will increment. If the case is m, you will increment upward. You are moving in upward direction, so you will increment by the distance. And you don't forget to break, since this is a case, you need to break for after every case. If you move in east direction, so you are moving in right direction. If he moves in west direction, you need to decrement right. And if he moves in south direction, sorry, if he moves in south direction, you need to decrement. So let's take a look at our code once. We scan the number of test cases, and for each test case we repeat this inner loop. After repeating, in each iteration you declare variable directions and you store the direction variable like 3 and 1 here in the sample input. After reading the direction, you will declare variables. This ch is for storing the direction, and distance is for storing the distance moved in each direction. And these two up and right are as explained here, so that we don't have to waste memory by declaring separate variables for separate directions. We only declare two variables. So after in each you need to loop our directions, and every time you need to read two characters and also discard /n. And if it is N, E or W or S, depending upon that we will take respective action and increment the respective variables. When we come out this while loop, we'll have the final distance of up and right, which is 5 and 10 here. So we have 5 and 10 finally. So we just need to compute this function. And to compute this function, our math.h provides two functions called square root and power. We can use this. So you need to find the shortest distance, right? Shortest distance is, so let's make it bigger. Shortest distance will be square root of x square plus y square. So for x square you need to increment right square. So for right, you say right comma 2. These are functions which are defined in math.h, and here you are incrementing up. So it's essentially right square plus up square, square root of that. Now you just need to print, and we're done. And don't forget to print a /n, since you can see in the output format after every output there is a line in between. So you need to make sure you print the line. Clear this as float. Let's run the code. So we have passed test case. Now let's submit and see. So we passed all the test cases. So this is it. We end our Tipsy guy problem. So the main idea behind the problem is to just have an idea about concept of coordinate geometry. Otherwise you might think in other parts, like the problem statement might deceive you because there's a minimum distance. So minimum distance is essentially the straight path from his doorstep to Bob's position. So thank you.